Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Today we will discuss about Islamic banking practice, the step 1 until the step 9. So in constructing the resilience index, there are 15 steps. The first is developing a theoretical framework. The second is transforming into index. The third is selecting measure. The fourth is determining weight. The fifth is index aggregation. Next is spectral analysis, setting threshold, signaling threshold, in-sample model, out-sample model, out-sample performance, determining the optimal level in index value, calculating the optimal level in real value, setting the heat map, and the last is visualizations. But today we will only discuss until the step 9 or in-sample model. So in this step 1, in the developing the theoretical framework, you can see here this theoretical framework. You can see here there are external risks and internal risks, like this. So we just continue to step 2 or transforming the index. So today we only use the data or initial data from 2019 until 2020. In step 2, we discuss, we only find the standard deviations for the NPF, CAR, IPR, and FDR. But before that, make a new table in here or index NPF for the NX CAR2, NX FDR, and NX FDR. The formulas is NPF sorry. First, we try to search the standard deviation first. The formulas is equal standard deviation point S, and then there's block all the data from January until December, and just enter that. For that, make a new table below the data. Make the year NPF, min NPF, CAR, min CAR, IPR, and min IPR, FDR, and min FDR. And try to find the mean NPF first. The formula is equal average, and just block all the data from NPF from January until December 2019, and just enter. Do also with the 2020 data, so like this. After that, try to find the index NPF. The formulas is the NPF in January 2019, and we minus with mean NPF, because in here we try to use the lowest data from 2019 and 2020. In here, in here 2020 is the lowest data from 2019. So that minus mean NPF. Don't forget to block your data. For your block data, just step F4 or F and F4. It's like this. See? So that we divide it with NPF. And then forget to lock the data also. And just enter that. That you can slide your data below, so it will directly match with your formulas. Okay, we continue to step 3. In step 3, we just find our best year, or we just selecting our best year. In here we use 2020 because 2020 is the lowest data in the our data. So we use 2020 as our base year. The step 4. After that, copy your data from here. Just copy your data and then put directly in here. That try to find the variance for NPF, variance for car, and variance IPR, and variance for FDR. The formulas is equal variance point S, and then block your index NPF from January until December. Just enter. Do also with car, IPR, and FDR. Seems like 2019, 2020. Just block your data. The formula is equal variance point S. Just block your data from January to December 2020 and just enter that. After that, try to make a new table below the data and put your variance NPF. After we got our variance, put your variance NPF in the below, just like this. Put our data in here and try to find the average for our variance from 2019 and 2020. So just enter the data, and we try to find the weight for our NPF, car, and IPR and FDR. The formula is the average of NPF, and then we divide it with the total of average from all NPF, car, IPR, FDR. Just enter that. Then we got the weight for NPF, car, IPR, FDR, and the total. After that, we try to put our data in here from the highest value until the lowest value. So the lowest data from NPF, car, IPR, and FDR. In IPR, the lowest data is here. Wait, car is here. The lowest. Wait here, and FDR, NPR, and the rest is NPF. Let's continue to step 5. So in step 5, we try to find the composite index aggregate. The formulas is INPF or index NPF multiply with the weight that we got from here. The weight, right? The weight NPF. The weight of NPF is 0.13. And don't forget to log your data, F4, type F4, and then plus iCar, multiply with the weight of the iCar, and then plus again IPR or index IPR, multiply with the weight of the IPR, and plus again IFDR, multiply with the weight of IFDR, and then enter. So you can just slightly scroll below, so directly will seem like the formulas in the first table. Okay, let's continue to step 6. So in step 6, try to find the let's continue. So in the step 6, the first step, we try to find the metric analysis dimensions. We try to make the form table, not kalimat table, just like this. NPF, iCar, IPR, FDR. So we try to find the metrics for our data, just like this. You can see as here, if INPF and the ICAR. You can see here INPF, the value of INPF is 1, and the value of ICAR is 6 or 5. So it means two twice, so it means two, so it means ICAR is two, so ICAR is 2 kali di atas NPF. So just we use once, so divided with the 5, the value of ICAR, just enter. So like this, IPR and ICAR, IPR, ICAR, so it means it's down. So the point is, so the value is 3. The FDR, and ICAR, FDR and ICAR. So it means it's up. So 1 divided with 3 is n. So that we make the total. The total. So just the formula is sum. Block your data here. Just enter it. So in step 2 is the normalizations. Make the table also. Try to find the criteria weight here. So the formulas is the value of here INPF and INPF from the step 1, and then divide it with the total for the here, total of INPF. Don't forget to log your data and just enter. That you can just like that. Sorry, you can just block your data. It will directly same like the first formulas, and then after that we try to find the criteria weights. The formula is average from here. It's also like this. The average for this data is block the data from left to right, and after that total. Don't forget to make the total summary. Sum this, sum ICAR in the below. So that is the 3. This next step is consistency. We try to find the consistency. So that make also the for kalimat the table. So the formulas is our value from the material estimation or from the step 1 in IPF and IPF. We multiply with criteria weight from INPF here. Multiply, don't forget to log and just enter that. For the weight sum value, we try to find the weight of some value here. The formula is equal sum, just log your data from left to right like this, and just enter that. For the criteria weight is from here. The ratio, the formula is equal weight sum value, and then divided with the criteria weight and just enter. And then this, we try to find the lambda max. Lambda max is the average from the ratio from INPF, ICAR, FDR, and IPR. From the CI, formulas is the lambda max minus 4, and then divided with or -3, -1. Sorry, just enter. We get 0.039. From the for the consistency ratio, we try to find this. We try to find the value of the CI divided with the random index 0.9. So we got the 0.044. Let's continue step 7. In here, first step, which make the 4 kali lipat table again. But first, we need to find the Granger causality causality test. We can use a few applications. So you can see here, we got the Granger causality. So here you can see here ICAR and INPF. ICAR and INPF. The value or the probability is 0.7, or it means 70% or 73%. It means it's on the medium value, or in the matrix value, it's on the medium. So we put here 2, because here if the medium is 2, if the height is 3, very high is 4, low influence 1, low influence is 0. You can just continue with here. You can see here INPF and ICAR. The probability is 0.79, or it means 79%. INPF and ICAR, just put 2 because it's medium, only the medium. You can see here IAPR and INPF. INPF. The value is 0.23, or it means 23%. So it's on the height, because the Granger probability is for the height is 10 until 50%. So its height, the value is 3. In this for the IAPR and ICAR. IAPR and ICAR here, the value is 0.09, or it means 9%. So it's below than 10%. So it's mean the very high. So the value is 4. We put here 4. After that, try to find the max. The formula is equal max, and make the total for INPF, ICAR, IPR, and FBR. Okay, and then just enter. The step 2 is normalizations for Y. Next, the for table again. After that, use this formula. We try to find the value for the INPF here and the max for the step 1. Don't forget to log again. Just enter, and then you get the value for this normalizations NPF. Just block your data like that. So show it all there, and like this. Then you got all the value for the step 2. The steps is matrix identity normalizations. In here, but before that, you make the table again. Just put the number like this. So the formula is, and from this identity matrix, and then minus with normalizations. Just enter. Also like this. Car minus with F here, minus with here. Yes, we got the matrix entity normalizations. Next is for inverse of y minus 1 I minus y. The formula is inverse for all, sorry, is inverse for the, just block all the data from matrix entity normalizations. Just block all data and then you got the value. Right? It's like that. Next is here, step 3, total relations matrix. The formula is equal m multiply, means here block the data from step 2 normalizations, and then block the data of the inverse of I minus y. It's like that. That just use enter. Sorry, enter, and then we get the value for step 3. Then step 4, the matrix. Step 4, you just copy your data in step 3 like that. And then step 5, threshold alpha value. Try to find the average from the T matrix in step 4. And then we got 1.39. Let's continue to step 8. Okay. In step 8, we try to find our signal in upper threshold and lower threshold. Next, again, we use our data. Our base year data is 2020. So we use our INPF, index NPF data. The formulas for the multiplier threshold for the signal. The data is, this the 1.39 we got from the average from the threshold upper value that we get from step 7. We put here, right, and then the signal, then for the formula for the signal is equal if INPF, index NPF, and then here, sorry, the formula is INPF equal if INPF, and then this one, our threshold upper value, and then here one, and then 0, and then just enter. So it means in Indonesia, jika INPF lebih besar dari our upper threshold value, our rata-rata kita sama dengan 1 dan sama dengan 0. And then jadi enter, and then just enter, and then we got signal for the upper threshold. And do also with the iCar, just it seems the formula is same, equal if iCar higher than our threshold, and then point 3,1, 2,0, and just enter. Then our lower threshold, our data for the lower threshold, the formulas is it's kind of different. The difference is just here. It's here equal if, and then IPF lower than here, because it's lower, so it means minus. So our threshold is minus. So minus 1.39, and then 0.1, 0.0 again, and just enter. And then we got the signal for the lower threshold. So let's continue to step 9, our step. Oh, HP filter. Oh, sorry. Wait. Sorry, there's some problem. Okay, let's continue. So in here we try to find the HP filter for the upper threshold and the lower threshold. Here, HP filter. First, we need to download the HP filter first in the Google. Just type HP filter and then just download, and then just add in to our Excels. So for the formulas, it's HP equal HP, and then block your data from your data INPF from January 2019 until December 2020, and then the comma again, and then here 14, then and then 14.400 is the lambda for the HP filter. Just enter that. For that, just we try to find the signal. The formula is same like in the step 8. Equal if HP here the before is HP filter bigger than 1.39 or our average threshold, and just the comma again 1, and the comma 0, and just enter, and just and then we get the value for our signal in the upper threshold. For the lower threshold, it seems, but the data for the average is minus because it's lower. The formulas it's different. Equal if HP filter lower than minus 1.39, and then 1 and then 0, and just enter. After that, we got the value for the lower threshold, for our lower threshold for the INPF. In iCar, it's also same. Just first try to find the HP filter. After that, we try to find our signal here from my sims equal if HP filter greater than 1.39, and then 1, and then 2, and then 0, and just enter. So it's done for the step 9. So I think that's all from me. Sorry for my short explanations. Sorry for my shortcomings. Thank you very much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.